Imagine asking an AI to book you a flight, and it just accidentally deletes your entire calendar instead.
Oh man, yeah, total nightmare.
Right. And that is exactly the kind of chaos we are trying to prevent on this deep dive. Today, we're tackling the 810-110 exam, diving into 5 crucial AI architecture questions. Let's get right into it. First up, how does a coordinator agent operate within a multi-agent AI framework?
Yeah, this is a fun one.
So, looking at the options, my gut says to pick the one where it handles all the tasks in a single reasoning loop. I mean, centralizing everything just feels way more efficient. Keep it all under one roof.
Well, that is a super common cognitive bias, actually. We assume the coordinator does all the heavy lifting, but the real answer here is that it delegates tasks to specialized agents and then combines their outputs.
Wait, so it isn't doing the work itself?
Exactly. Think of a general contractor building a house. You definitely do not want your contractor pouring concrete, wiring the electricity, and, installing the plumbing all by themselves in one chaotic frenzy.
Okay, yeah, that makes a lot of sense. They hire the plumbers and electricians.
Yep, the coordinator just manages the workflow and collects the results. Oh, and it definitely isn't just sitting around fine-tuning model weights, which is a really sneaky distractor option on this exam.
Yeah, good catch. But if an agent is just delegating and looping through tasks, isn't that just a really fast generative AI? Which actually brings us perfectly to our second question. What is the key difference between generative AI and agentic AI?
And there is a massive trap waiting for you here.
Yeah, because one option claims generative AI uses RAG, while agentic AI cannot. And I could totally see someone falling for that if they're rushing.
Oh, absolutely.
Mm-hmm.
But agents definitely use external data and tools. The real distinguishing factor, the right answer, is that generative AI generally gives you single-turn outputs, while agentic AI runs multi-step loops.
Single turn versus multi-step, got it.
Spot on. Generative AI is like a search engine just giving you a recipe for dinner. Agentic AI is like a personal assistant who finds the recipe, orders the groceries, preps the kitchen, and, iterates if an ingredient is missing.
Okay, so it plans, reasons, acts, and loops. But if an agent is actually taking action in the real world, what kinds of tasks are we trusting it with? Because our third question asks you to identify a specifically agentic use case over a standard generative one.
Let me guess, you are drawn to the language translation option.
I mean, yeah, translating a short email involves immense semantic complexity,
It is complex, sure, but it is still fundamentally a single-turn generative task.
Yeah.
You put text in, you get text back. The correct answer is autonomously fixing a build.
Oh, I see. Because fixing a broken software build requires actual planning. The agent has to use tools, diagnose the error logs, attempt a fix, and then loop back until the code actually compiles.
Precisely.
Right.
Translating an email or summarizing a meeting, those are single-turn outputs. Autonomously fixing a build demands that multi-step reasoning loop.
Makes sense. But to autonomously fix that build, the agent is constantly reading log files and writing reports, which requires it to radically reshape data on the fly. And that's our fourth question. What process occurs when an agent converts a CSV list into a markdown table for a final report?
A lot of test takers jump straight to data classification here.
Which is tempting, but classification is really just assigning labels to existing data.
Right. The correct answer is data transformation. You're fundamentally changing the structure.
So it's like taking a stack of unorganized business cards and sorting them into a Rolodex. I mean, the information is identical, but the structure has been transformed to be useful.
Exactly that. You aren't dropping records, so it's not filtering. You're just reshaping it.
But here is the catch. To successfully transform data and pass it to an external API, you need strict rules. Which leads to our final question. Why do we provide a JSON schema when configuring tool use for an AI agent?
This one tricks a lot of people.
Well, there's an option claiming it's to encrypt the external service payload. And I've got to admit, that sounds like a rock-solid security best practice.
It sounds wonderfully technical, but it's a complete fabrication. A JSON schema doesn't encrypt anything, and it doesn't reduce token counts either. The actual answer is that it defines the required parameters and data types.
Wait, why is defining that so critical, though?
Because large language models just naturally want to be conversational. Without a strict JSON schema, an LLM might inject pleasantries like, "Here is the data you requested," right before the code.
Oh, wow. And that conversational filler would instantly break the API receiving the payload.
Exactly. The schema acts as a strict contractor blueprint so the agent doesn't send gibberish.
All right, that wraps up our questions. Let's zoom out and see what we've learned.
When you look at all of this together, a clear picture really emerges. We started with the foundational idea of multi-agent coordinator orchestration, proving that complex systems rely on delegation.
Which naturally helped us define generative AI versus agentic AI. We saw how those multi-step loops power true agentic AI autonomous use cases, like fixing broken code instead of just translating it.
Yeah, and to make those use cases work, we explored agent data transformation to reshape outputs. And finally, the absolute necessity of a JSON schema for agent tool use, to keep
Yeah.
all those automated API calls from crashing.
Seriously. So, leaving you with this thought to chew on. When agentic AI can autonomously plan, iterate, and fix our broken builds, what becomes the most critical skill for a human engineer?